Hi, I'm Mr. V, and this is day 7 of 2021. We had pictures today, and so half the class was gone at any time. And my computer, projector failed. It had lost its ballast, and so I was unable to project things. And so I decided to, instead of doing the lesson I planned in Desmos, we'll put that off until Monday, but whether I have a projector or not. But today we did some link sheets. We did 2 link sheets, and I'd like to go through these here with you now. And you should try these on your own first, if you can, and then we'll um, then look at what we're actually doing here. So the first thing we do when we do a link sheet is we read the story. Dan painted his room at his parents' house at 8 square meters per hour. After 3 hours, he had 28 square meters left to paint. How large in square meters was his room? How long did it take him to paint it? After we read the story, the first thing we really do with the problem is we have to define what the variables mean. And this is the first thing you do at any time. And you want to write the independent variable on the x-axis. That's usually what is the convention. So the question I have is, does the time that it takes him to paint depend on how many square meters he's painting? Or does however many square meters he's painting depend on the time? So I think you should have chosen the first one. The first one, the independent variable is going to be time, and usually that's the case. If you have time, you would put it on the x-axis. Not always, but most of the time. So we're going to put the x is going to represent time, and that's going to be in hours. So the units is hours. And the other unit is going to be meters, square meters. And I could put SQ meters. This is area. And I could put square meters. I'm just going to put it like m squared, like that, meters squared. So you can fill that in here and here as well. Let's see, the x represents, and so I'll put the x here as hours, and the time is going to be in meters squared. On the graph, the one that goes on the horizontal line, this is horizontal, this is vertical, h comes before v, x comes before y. This is my x-axis, so this will be the hours. And this will be the vertical, but this will be the meters squared. And so now the next step is to find some points to populate this graph with. And I've asked several people, can you give me a point? Some people said right away that they could do 1 and 8. And I said, well, how do you know? Well, because for every hour, he paints 8 cubic meters. And I said, well, how much is it at 2 hours? And they said, well, that's 16. How do you know? Well, because it's 8 difference. This is going to grow by 8 for every hour here. Notice this is my change in y is 8, and my change in x is 1. Where did he begin? We didn't start with that, but at the very 0 hour, he started painting. So he had not done anything at 0 hour. So this is a very important one as well. Notice this difference is 8. This is 1 as well. And at 3 hours, it would be 24. And you could go all the way up until you figure out how much he's going to have done. But I want to look at what it says here. After 3 hours, he had 28 square meters left to paint. Where on this table do we put 28? Do we put it here? Do we put it here? Do we put it somewhere else? And just think about what it's saying. He's already painted so much, and he has this much more to paint. So I could tell you how much total square meters it would be. And actually the number goes right here. This is my 28. It's going to be 28 left. When I add 28 to 24, I get 52. So this room is 52 square meters. That's the answer to this one. I still need to know how long that's going to take. Maybe you count up. You go at 4, it's going to be, 4, it's going to be 32. At 5, it's going to be 40. At 6, it's going to be 48. At 7, it's going to be 56. Wait a minute, that's too many. So you're going to come up with 6.5. But we'll talk about that in a minute. Let's look at the hours here. So this is going to be more than 3, probably twice as many. So we're going to label this, each one of these will be 1. So 0, 1, 2, 3, 4, 5, and 6, and so forth. On the y-axis, we have to go up to 52. And we've got 10 here. So I'm going to do every other one. We'll do This is 10, 20, 30, 40, 50. 52 will be right above it. We can plot the points. You have 0, 0. And I would suggest that you write the coordinates when you do this. 0, 0. We have for every 1, it's going to be 8. So it's going to be just under 10. 1 is 8. And then 2 is 16. So it's just over this number. This would be 15. So 2 and 16. And 3 is 24. So let's see here. 5, 10, 15, 20, 24, be up here somewhere. And you could draw a line, and you can use your line tool. It's going to go something like this. And you'll notice at 52, right up here, if you look down, it should be around 6.5 hours. And I think it's going to be 6.5 hours, but I'm not sure. Not at this point. We know we have a graph. We have a table. We're missing this number from the table. That's going to be the answer here. How long did it take you to paint it? What's the y-intercept of this equation? The y-intercept is where this line crosses the y-axis. Yeah, but what is it? What's crosses it? 0, 0. What does that mean? The 0, 0 means at 0 hours, he's done 0 meters squared. So he hasn't even started painting at 0, 0. My y-intercept, which is the b value in our equation, y equals mx plus b, this is 0. And what is our slope going to be? Well, I've told you before, the slope is the change in y over the change in x. It's the common difference. How much does it grow by each time? It's growing by 8. So I could write the equation to this down here right away. Y equals, my m value is 8. That's 8. And I've got an x. The m value is not 8x. The m value is just the 8. And then my b value is 0. So this is the equation of the line. If I'm looking here, I want to know what is the y value, what is the x value when the y value is 52. So I can substitute 52 is equal to 8 times x. And when we divide both sides, doing the inverse operation to isolate the variable, we're going to do get x is equal to 6.5 or 6.5. That's the number that goes here, and that's the answer to this part of the equation. Now, you've got it all filled in. But I want to make you aware of something else that we discussed in our discussion of this, which is really important because it may play down the line into how you think about these things. We start off with a common difference. The common difference is 8. Then we're going to multiply that by some number. We're going to start at 0. We're going to go up to some number. You could call this x sub 1, or we could call this, we're going to go up to some number. We'll just call it x sub 1 for now, or x sub 2. Because this is where we're starting from. We're going to go up this many times. And this is going from 0 to x is going to be x. So this is x sub 2 minus 0, which is x. And at this point, we're at 0. At this figure, we're at 0 because we started at 0. So this is going to equal to my new value of y. Folks, that's my equation. 8 times x is equal to y. This is another way of thinking of it, though. We have a common difference. How many times are we going to multiply by the common difference between the 0th term and the x term, x minus 0? And you started at 0, so we have this. The other one that some of our classes looked at was this one, not the mole. Mr. Mole, we read the question. Mr. Mole left his burrow that was 7 feet below the ground. He started digging deeper, and he set it at a constant rate. After 6 minutes, he was 16 feet below the ground. At what rate was he digging? So if we look at this, here is the ground level, and there's his burrow, there's his hole, and he goes down, 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 and then he has a burrow. And oops, there he has a burrow. And he starts digging, and he's going to dig down at a certain rate. He's going to go down further at a certain rate. This burrow is 7 feet below the ground. So what are we going to let things represent? Well, we have feet, and he's digging at 6 minutes. So it's time. We have the x is time, and x is a independent variable, so we'll call it time, and this is in minutes. And then we have the other one, which is depth, or we'll just say how far down it is, and that's going to be in feet. So this is feet, this is minutes, and y is going to be feet. So y is feet, and this is in minutes. That's the first thing we would do, is we read the problem, define what our variables are, start filling in the chart. Now we need 2 points in order to draw a line. What are 2 points? He started digging from his burrow. So at 0 minutes, where was he? Some people said 7. You mean he's way up here? 7? No, he's down below the ground. It's -7. Did you notice that? His depth is down. And then it says, after 6 minutes, he's 16 feet. Minutes, feet. 6 minutes, he's at 16 feet below ground, which would be a -16. What's my delta x here? 6. What's my delta y? My change in the y direction. To go from -7 to -16, what is the change? We have to subtract 9. Now we know the y-intercept. We could go 0, 1, 2, 3, 4, 5, 6, 7. And then at 6 minutes, 1, 2, 3, 4, 5, 6. He's going to be at -16, which is right here. So this is the way that he's digging. And if you went deeper, we keep going. So this is my graph. And I could put those points on here. 0, -7. This is at 6 minutes. 6 minutes, it'll be at -16. And how do I know that? Because this is 20, and I can just count up 4. 1, 2, 3, 4. That's how I got the 16 so quickly. What's the rate, or the common difference here? What's the slope, the rate? So change in the y over the change in the x. That's going to be -9 over 6. What is that over 1? If you plug this into your calculator, you get -1.5. Folks, that's my slope. That's my rate. That's at what rate he was digging. -1.5 y feet per minute. Feet per minute. That's what his rate was. What's the equation? Well, where does he start? What's the 0 value? What's the y-intercept? It's -7. My b value is equal to -7. And we could write this in the form y equals mx plus b. So we have y equals, the m is going to be -1.5. Then I have an x there. The slope is not -1.5x, it's -1.5. And then we have x in the equation, and then we have plus -7, because that's where he started. And that's the equation of the line. Now we could also do this using our common difference of -1.5. We're going to go from the first step to the 6th step. So to go from the first step all the way up to the 6th is going to be a difference of 6. So I'm going to have 6, and it's actually 6 minus 0. But we have to add in where we started from. We started at -7. -1.5 times 6 is going to be -9. -9 plus 7 minus 7 is going to be a -16. You see how that works? I could have written -1.5 times, instead of at 6, we could have put x, some unknown, or x sub 2 minus 0. The 7 goes with the 0. This is plus a -7. And this would be y sub 2. So I could find any y. This is my equation. It turns out to be the same equation as we have here. Pretty cool? I hope you're getting this. Good luck and success.